Okay, so thanks. My talk is entitled Explainable AI, Beware the Inmates Running the Asylum, or How I Learned to Stop Worrying and Love the Social Sciences. And so I'll start with the story about how I came up with this title. The little subtitle there is just a reference to a Peter Sellers film. It's not that important. It was a bit of a joke, but the title about Beware the Inmates Running the Asylum actually comes from this book, which is called The Inmates Are Running the Asylum, by an author called Alan Cooper. And it's a book about human-computer interaction. And basically in this book, Alan Cooper asks the question, if we train software engineers for 4 or 5 years to build software and we think they're really skillful people, why is so much software that we build just so garbage? And why do we hate to use it so much? And he comes to the sort of hypothesis that the reason is that we teach software engineers how to build software architecture, how to test software, how to do programming, but we don't actually really teach them how to get into the mind of users and go out and capture the kind of things that users care about. And so therefore, what happens is software engineers just build products for themselves. And this is what he entitles The Inmates Running the Asylum. It's like letting the inmates run the asylum. They'll run the asylum the way that they want it here. And he introduces a whole lot of techniques around HCI. And if you're familiar, in fact, with personas as a use of a design pattern, this was the first book that did it. So what's this got to do with explainability? Well, I wrote a paper called The Inmates Are Running the Asylum, or How I Learned to Stop Worrying and Love the Social Sciences, with two of my colleagues, Piers Howe and Professor Liz Sonnenberg, where we kind of argued that explainable AI was in the same state at that particular point in time. This was in 2017. And in that paper, we looked at a whole lot of sort of a contemporary research that was coming out in explainable AI. And we analyzed some things such as how many human studies were being performed to actually see whether the explainable AI techniques were useful for people to make decisions or build trust. And how many of them were informed by, let's say, social science research on how people make decisions and how people explain things to each other and these types of things. And in 2017, the answer was grim reading, that it wasn't very much. And we made the point that explainable AI was kind of like the inmates, which were people like me, computer scientists, were writing explainable AI tools just for themselves, and they weren't going to be any use for things like actionable recourse, as we saw Rachel talk about in the last talk here. And so in that paper there, and another paper that I'll talk about in a bit, there we go, we kind of talk about what the scope of AI really is. And really we say, well, there's clearly computer science on one side or artificial intelligence on the other. But also we were sort of arguing that people should be bringing in human-computer interaction and how people interact with these tools in order to try and understand them. But also the focus of this paper was on cognitive and social science, and that we felt that at that particular point of time, if we went and looked at how people make decisions, but probably more importantly, how people explain complex phenomena to each other, that could provide us with some foundational knowledge on how machines could explain their own decisions to people as well. And we kind of made this observation here that really, if you take the intersection of those three things, we get a field called human AI interaction. And at that particular point in time in 2017, there was lots of people working in this space of human AI interaction, but the explainable AI community was sitting here. But really, we felt really explainable artificial intelligence it's just another form of human AI interaction. It's just one that we're helping people to understand where decisions come from. And that's where we should be sort of positioning the work at that particular point in time. I'm kind of pleased that's 4 years old now, that paper, that the field has moved very rapidly towards this middle section here. We see workshops at conferences like CHI. We see panels at CogSci, a conference called CogSci on this topic, as well as lots of people in AI working with in cross-disciplinary teams on this problem. So I want to give an example of why I think things like infusing cognitive and social science is important. So let's take this simple example here. This is a toy example. I'm not saying it's representative of anything. I just want to give you an idea of this here. Let's say we have someone who's made a doctor's appointment and is saying, I'm coming to the doctor because I've got 3 things I want to discuss. I've put on a little bit of weight unexpectedly recently. I've been suffering from fatigue and also nausea. And before the patient comes, the doctor has a quick look at the profile and has a look and says, well, I know quite recently this patient injured her ankle. So she's probably stopped exercising. And that's about 80% chance that I think she stopped exercising. I also know there's been a bit of mononucleosis going around, which would explain the fatigue. I think it's about 50% chance she might have mono. I know that her kids both had stomach virus in the last week. So that would explain the nausea. I think there's about a 50% chance of that. But the last time we spoke, I remember she said she was trying to get pregnant as well. And the pregnancy would explain the weight gain, the fatigue, and the nausea. Now, I can't see the audience here, so I can't do the usual poll I would do. But maybe I want you to all pause and think a little bit about yourself. Is if you were the doctor and you had to explain what's the most likely cause of the symptoms here, would you say that the most likely cause, what's the best explanation that you could give for these things here? Would you say that it's because the patient has stopped exercising, has mono, and has stomach virus? Or would you say that she's pregnant? I'll just give you like 15 seconds to think that through while I take a sip of water. Right, so what's the best explanation? Well, the answer is there is no answer, right? Because it really depends on how you define best. And I made a slip up and said the most likely when I asked the question earlier, but some people would say the most likely explanation is the best explanation. So if we assume these three events here are independent from each other, and we multiplied 80 by 50 by 50%, we would know that the probability of these three things all simultaneously being true is 20%. So that's the most likely explanation. But actually, this is a study run by some cognitive scientists probably about 15 years ago that showed that overwhelmingly most people would choose pregnancy as the quote unquote best explanation. And the hypothesis for it is that people prefer smaller, let's say shorter, a fewer number of causes that explain multiple events rather than multiple events that explain other multiple events. And in fact, they in that experiment, they varied the probabilities and showed that, putting three things together, it has to be roughly double the likelihood before people would start choosing that. The majority of people would start choosing that. And so this is just one toy example of a type of study of how people explain things to themselves and how people judge explanations that people would give to them and the plausibility of those. That shows that it's not a mathematical problem. It's not just multiplying three things together to come up with an answer here. There is some sort of cognitive biases we have or preferences we might have for shorter experiments. But it doesn't end there, right? More recent experiments have shown actually, if it's a slightly more complex phenomenon, people would prefer a more complex explanation than a simpler one. And quite recently, we've submitted some work in the sort of human machine interaction area that supports that as well, that there's actually, there's sort of a mid-level that too complicated obviously is overwhelming, but actually people do prefer quite a bit of detail for more complex situations. And I guess the point we made in the paper that back then was, if you're working in explainable AI, surely you should know about some of these things here. This is just one example of one little study, and you should know about these things. But of course, going out and learning about cognitive science is pretty hard. So when I was on a sabbatical in 2017, I went out and did a survey on how do people explain stuff to each other from the cognitive science, cognitive psychology, social psychology, and philosophy perspective. And I published this paper in AIJ in 2019, I think, about this. And what I want to talk about today for the rest of the talk is just give you probably the three most important lessons that I learned from that work there that has influenced my thinking, and it's influenced quite a bit of other groups as well in the last few years, I think. Okay, so what are these key lessons that I learned? The first one is that explanations are typically contrastive. In fact, a lot of social scholars will tell you they are always contrastive. And this is a quote from Dennis Hilton, who I had the privilege to work with a little bit when I was in Toulouse in 2017. Unfortunately, passed away earlier this year. Who's a brilliant social psychologist working on explanation. And he says that the key insight is to recognize that we don't really explain why events happened. We explain why one event happened rather than some other event, which was usually the thing we expected. So usually we want an explanation when something happens, we were surprised. oh, I thought A would happen, but B happened. So we actually want an explanation, not why B happened, but why did B happen rather than A? Now, why is this kind of important? Well, it has quite some cognitive impacts on how people would expect explanation and how they would use them. And in fact, I'll show you this example here. This is just a crappy little toy example I came up with for a paper that was as simple as I can do here, but it's about this idea of contrastive explanation. This relates precisely to what Rachel was talking about in actionable recourse. And in fact, I disagree with her statement that explainability is not enough. You need actionable recourse. I think explainability should be covering things like, I think we should expand our definition of what we mean by explainability to cover actionable recourse explanations. And this is an example of one you can give, which is called a contrastive explanation. So imagine that we ask the question, here we've got a simple, let's say it's an image classifier, and it can identify arthropods like spiders, beetles, bees, based on the properties that they have. So a spider has 8 legs, no stinger, eyes, etc. And someone asked, why did you classify this image as a fly? And so you could say, well, I can give a nice explanation of that by just simply highlighting, well, because I recognize that it had 6 legs, a stinger, 5 eyes, has compound eyes made of other eyes, and 2 wings. And that's the properties that we have for a fly. And that's probably not a bad explanation. But the social science literature says, well, mostly people are going to want to know this when they thought it was something else. So let's say they said, well, actually, I thought it was a beetle. Why do you think it's a beetle why do you think it's a fly rather than a beetle? And that's what's called a contrastive question. And we could give the following answer. We could say, well, I'll explain the properties of a fly. It's 6 legs, a stinger, eyes. And I'll explain the properties of a beetle. It's 6 legs, a stinger, 2 eyes, these types of things here. And then you'll know why I said a fly instead of a beetle. But actually, that's a terrible explanation. Most of us would hate that explanation if we received it. What most of us really want is what's called, what a philosopher, Peter Lipton, calls the difference condition. And Lipton would say, and it's the good explanation to why is it a fly rather than a beetle, is just to highlight these 2 things. Well, a beetle has 2 eyes, a fly has 5 eyes, and I recognized there was 5 eyes in that image. Because all these other things, the number of legs, the stinger, the compound eyes, the wings, they're the same. And so none of those are relevant from an explanatory perspective to answer this question, why is it a fly rather than a beetle? They're not relevant. They should be excluded by the sort of Grice-Maxims rules of conversation. And we should focus down on those differences between those 2 things rather than giving the complete explanation of both. It's cognitively easier to process because it's smaller, but it also answers the question far more specifically. And so from an explainable AI perspective, if we can figure out what the 2, let's say in this case, the 2 classes would be in a classification decision, then we can come up with a shorter, easier, more relevant explanation to understand. For this example, okay, there's 5 features, it's trivial, but we know that, for some machine learning, you want to do credit scoring, those kind of, there's thousands, if not tens of thousands of features on those types of models there. So there's an opportunity here to break it down from 1,000 features down to maybe half a dozen. We should operate on that. So that was lesson number 1, that explanations are contrastive. I think a lot of people have adopted this in the last couple of years. I see a lot more work. I see this term popping up a lot in the literature. The second one is that explanations are social. Here's another quote. Again, it's from Dennis Hilton. I read stuff other than people from Dennis Hilton. He just happens to come up with very quotable text. And he says, causal explanation is a form of social interaction. And the verb to explain is 3 parts. Someone explains something to someone else. And a causal explanation takes the form of rules of a conversation, adhering to things like Grice's maxim. And I think this is an important lesson to learn, is not so much that explainability should be a person conversing with a tool, but that it should be an interaction. Okay, it is some sort of interaction here. And our recent research from a couple of years ago in our lab showed that when people expect explanations, they do expect it to be somewhat of an explanation, even when they're talking to a machine, where they'll ask one particular question, they'll get an answer back, and that will just drive more questions So you might say, why did this happen? Well, because there was this bit of information. Can you explain more about how you came up with that bit of information? And in fact, sometimes people would argue back, well, that you might think that's what happened, but I didn't think, I thought the information was wrong, and they can get into these types of loops here. And the real point here is not so much that we should hold a conversation, but that it should be interactive and it should be incremental. It's really unlikely that we'll have really good explainable systems where someone will ask a question and there'll just be, there's an answer and that's the explanation, and the process will finish and they'll be happy with it. Normally they'll have to follow up with things. And it's a job of designers to think about what are the different tools that people are going to use to explore tools like this. And the third lesson is that explanations are selected, right? Any event has multiple causes, sometimes tens of thousands of causes, but we tend to be really good at just picking out a couple of things to help somebody else explain something. Now, I don't want you to read all the text on the screen here. I just want you to think about this last thing here. This is about Mr. Jones, who was in a car accident. And before the car, and the last bit of the text says that the day was exceptionally clear and Mr. Jones told his friends that he would drive along the shore to enjoy the view. He ended up being in a car accident and was injured. And this is from an experiment run by Daniel Kahneman and Amos Tversky, who you might know from this very famous book here. They did a lot of work on explanation here, and they took this vignette and varied all of these little sentences at the end about what happened to see how people focus on why did Mr. Jones end up in an accident here. And this particular example, I've highlighted this one because Mr. Jones did something unusual, which was go home a different way than he normally did. People tend to find that really causally relevant compared to some other aspects here. And from reading a lot of literature around how people select explanations, I kind of pieced together a sort of basic model of this kind of biases, these preferences that people have for explanations. So if we had, say, some timeline of events that had occurred along this line here, we can kind of think about people prioritizing things like this. So if we had multiple causes, the most recent ones seem to be more relevant. People prefer the more recent things to explain things, which kind of seems clear because it's more immediately causally relevant to us, perhaps because it happened more recently. But if there's something abnormal that happened, well, we tend to sort of trace through the temporality and back to that abnormal thing. We might skip over something as a reason. We might say, well, that was a cause, but really this abnormal thing is more relevant from an explanatory perspective, like Mr. Jones going home in an unusual way. And that kind of makes sense as well. If there's a really strong reason that it always causes a particular event, well, that's not very, very useful because we know that's happened. Where if something unusual causes it, well, that might be something that we need to care about. But if something, let's call it intentional, an intentional action by somebody to do something, if that's there, that tends to prioritize over temporality and abnormality. If there was a human in the event that did something, that tends to take precedence over, let's say, physical events that happen. So it's like human intentionality seems to be explanatory relevant for us. And finally, if something is, let's call it, considered immoral, an unusual situation that someone judges as immoral, that tends to be weighted even heavier. So in the Mr. Jones example, where he went down on the shore, similar vignettes in similar other studies have shown if Mr. Jones stopped off on the way home to buy groceries, that wasn't considered a cause. But if he stopped off to buy cigarettes and alcohol, it was considered a cause because that seems to be, quote unquote, less moral. And the point here is not that I care about it, whether people do immoral actions. The point here is that when we have a lot of causes, even some of them that have quite a strong weight on decisions being made, tend to be classed as quite irrelevant if they happen regularly and these kind of things here. And there are other things that people find more explanatory relevant to help them understand where things come from. So those three lessons here, we've been applying them in my research group for a while here, and our experience is applying contrastive explanation, trying to do a bit of stuff on interaction and temporal selection, and also looking at causality as a way to help people understand things. We've been applying those insights over a range of different techniques, such as reinforcement learning and AI planning, machine learning, computer vision, and some multi-agent systems as well. And in a kind of range of domains, I've been working a lot with defense, looking at search and rescue patterns, illegal fishing, not doing illegal fishing, detecting illegal fishing boats. We've also been looking a bit at credit scoring, more recently at medical imaging, and quite a bit at playing games for warfare purposes. And we've had quite a bit of success just taking some pretty basic foundational social science techniques, trying to apply them in this sense, and having some reasonably good results in some domains. So the key takeaways that I want you to think about here, if you're an inmate, if you're a fellow inmate, which I think a lot of this crowd will be, you're a data scientist, you're a computer scientist here, just remember that things like XAI, it's not just a technical problem, it's actually a social problem. You're explaining to somebody, and you have to think about them as your audience. And there are some insights that you can take from social science. And in fact, some people in social science already have a better idea of what explainable AI should look like more than we do. They just don't know how to implement it. So there, and doing validation on human studies is hugely important in this case here. But if you're sitting in the audience and you're, let's say, a warden, you're not a computer scientist or a data scientist, you're a social scientist or a philosopher or someone in maybe HCI, I want you to consider how you can help improve some of the cross-disciplinary links in this work by getting involved in this work. I'm very lucky to work with the cognitive scientist, Associate Professor Piers Howe, as well as Eduardo Veloso and Frank Vitire from our HCI lab, and students in that lab as well, that really gives some of our work a great edge. And help to study the design of interactions between explainable machines and people, and help computer scientists who maybe can't do human-centered studies quite as well to do these particular studies. So thanks very much. I think my time's up. Thanks very much for the invite. I'm glad to have been a huge face on the screen here. Unfortunately, I can't join for much of the rest of the day because I have an event, but I've really enjoyed the talks so far.